So we're going to do these four words: protons, neutrons, electrons, and the nucleus. Protons are a positively charged particle of the atom. And so just kind of like a battery has a positive side and a negative side, atoms also have positive particles and negative particles. Particles that have a similar charge repel each other. And so two protons don't like to be right next to each other. They try and push away from each other. Neutrons are a particle of the atom with no charge. So they are not positive or negative. So they don't repel any type of other particle. An electron is a negatively charged part of the atom, and they go around the nucleus. So they have orbitals around the nucleus, which was our fourth word, which is the center of the atom. The center of the atom has both the protons and the neutrons. Now, because protons don't like to be next to each other, those neutrons act like the kind of glue for those protons. And so the neutrons are usually in between the different protons, and they help keep them together. And that nucleus is very dense and very small. It's where all of the weight of an atom comes from, is in the nucleus. And then the electrons going around in the orbitals are spinning super fast, but they never are next to each other, and in between them is tons of empty space. So if we had a particle or nucleus the size of one of our models here, or one of our little, I think I have one on my desk actually. If we had a nucleus the size of this, to the first electron, we have to go over 20 meters. So 20 meters, let's see, how much would that be? That'd be like 20, close to 20 yards. So if this was the size of a nucleus, before you got to another electron, you have to go at least 20 yards. So most of an atom is very much empty space. The electrons go around the nucleus so fast that they're considered to be everywhere and nowhere at the same time. It kind of doesn't make a whole lot of sense, but you think about it like a fan. That fan, when you look at it, it's going fast. It looks like it's everywhere, but it's also at no point in particular when you're watching it. Unless you were to stop it or slow it down, then you could see where it's at. So the electrons are the same way. They do have a location, but while we're watching them move, it's really hard to tell where that is. It just looks like they're everywhere. One cool thing about electrons and protons, because they push against each other, they don't like to get close, and everything is surrounded by electrons moving really fast. That means that no two atoms actually ever touch each other. Every single atom that makes up the universe has atoms whirling around it, and so those electrons never get close enough to touch. So if you think about it, that means when you feel things, like when you touch the table, all you're actually feeling is pressure. You're not actually feeling the table because your electrons and the atoms of your hand are repelled from the electrons off the table. And so even though it's a tiny, tiny amount of space, there is always space between your hand and the table. And so all you're really feeling is just the pressure of the other electrons pushing on your electrons. Okay, any questions about these four words? Okay, so we're going to today make a model of an atom. Oh, did people still need this? Did I just erase it too quick? Sorry. Okay. And if you didn't have this one, it's a negatively charged particle of the atom.